All right. Let's look at the first half of section 7.2, just talking about in behavior. First of all, let's talk about what this notation means. You'll see something like this, and this is read as x approaches negative infinity, f of x approaches blank. So again, this arrow here is the word approaches. Oh boy, approaches. So it will either be positive infinity or negative infinity. And what we really mean is as x approaches negative infinity, that means like as the graph moves to the left towards negative infinity, talking about, on an axis, as we move in this direction. What is the graph doing? And you might hear this referred to as the left hand. It's talking about the left side of the graph. If you see something like as x approaches positive infinity, that means as the graph moves to the right. Towards positive infinity. So as x approaches positive infinity, we're talking about the right hand. And of course, f of x is y. So it's talking about as the graph moves to the left, what does the y value do? Does it go up or down? And then as the graph moves to the right, or as x approaches positive infinity, what happens to the right-hand side of the graph? Does it rise or fall? So, what determines end behavior is positive or negative. And we're talking about the leading term. And even or odd exponent. So we could have 4 different cases. Whatever number you think about these as, I think about like an x squared as kind of our first case. For an x squared, the left hand goes up just as the right hand goes up. And for x squared, we can see that we are positive and even. Again, this is what determines end behavior. And I always think about x squared as what we kind of envision here. So here, the notation that we use is as x approaches negative infinity, meaning the left-hand side of the graph, f of x approaches, and then you'll be asked to state. So again, like from the vertex, from the right-hand side of the graph, as no, I'm sorry, it gives it to you in left to right. So as x approaches negative infinity, y also approaches or goes upwards towards positive infinity. So again, as x approaches negative infinity means as the graph moves to the left, what happens to the y value? And it goes up, so it moves towards positive infinity. As x approaches positive infinity, what does y approach? And so as the graph moves to the right, as the graph moves towards positive infinity, we can see that the y value goes up. And if it's going up, we state that that f of x is approaching positive infinity. Again, 4 cases, and we'll look at a couple examples. Negative x squared, and again, this is an example. It could be, negative 55x to the power of 100. As long as the leading term is negative, and we have an even exponent. This is what determines end behavior. So this makes a U shape opening downwards. So here the left hand goes down, the right hand goes down. In Alex, it will give you this notation. As x approaches negative infinity, f of x approaches blank. And then it will give you the right-hand side of the graph. As x approaches positive infinity, f of x approaches, and then you fill in the blank. So again, it gives it to you from left to right. As x approaches negative infinity, as we move to the left, the graph goes down. And going down means towards negative infinity. But also, as we move to the right, the graph goes down. So as x approaches positive infinity, y approaches negative infinity because the graph goes downwards. And then what about something like x, or I used to think about it as x cubed. I don't know why I didn't just think about it as x to the first power. If we did y equals x as a graph that moves up from left to right, that's the linear parent function. X cubed, that linear is that kind of John Travolta disco dancing shape. But either way, notice that since we are positive and odd, now our exponents are odd. It's not the coefficient. Oh, I should make that clear. We don't care about the coefficients when determining end behavior. Students will look at the coefficient and see whether that is odd or even. That doesn't matter, just if it's positive or negative. So whether we have x to the first power or x cubed or x to the fifth, x to the seventh, any of these graphs will go down on the left hand. So left hand down. And we see that on the right hand, it's going up. So as x approaches negative infinity, y approaches. So as we go down on the left-hand side, as x approaches negative infinity, the y value is also going down. As x approaches positive infinity, either of these graphs, as we move to the right, we see that the graph goes up. And if it's going up, then it's moving in the towards positive infinity. The last case that will determine end behavior is something like negative x or negative x cubed. Negative x is a linear equation with a negative slope, so it goes down from left to right. And this negative x cubed, if you graphed it, it would go like that. So now we are negative and odd. Again, it's the coefficient or the sign of your leading term. Is it positive or negative? And then is the exponent odd or even? So here we have the left hand going up and the right hand going down, which means as x approaches negative infinity, as the graph moves to the left, the graph is going up, which means f of x is approaching positive infinity. And as x approaches positive infinity, the y value, or f of x, as the graph moves to the right, the graph also goes down, meaning we approach negative infinity. So let's move on to an example. Turn the page. Number 1 in 7.2 looks something like this. Now you could graph this and try to look at the end behavior, but it's important to understand that none of the stuff in the middle really matters. It doesn't affect the end behavior. The only thing that affects the end behavior is the leading term positive or negative, and is the highest exponent odd or even. So we are negative and even, which I think of as like negative x squared, which opens downwards. So we know that as x approaches negative infinity, the graph is going down. So f of x approaches positive infinity. What about the right-hand side of the graph? As x approaches positive infinity, f of x is still going down. It's going down on both the left and right. Forgot to put a negative sign. So the y value is going down towards negative infinity both times. Another example. Again, the polynomial itself doesn't matter. We can have all of these x terms going in descending order. But what determines end behavior is the fact that we are positive and the fact that we are odd, which is something like y equals x or y equals x cubed, a line that goes up from left to right. So as x approaches negative infinity, the y value falls, or the left hand falls. Different ways you might be asked this. Left hand falls, right hand rises. Or, this is getting tedious to write down. As x approaches negative infinity, y, or f of x, approaches negative infinity because it's going down on the left hand. And as x approaches positive infinity, the right hand, that's the positive, if you want to think about it that way. This is the right hand. This is the left hand. Ooh, almost out of room. As x approaches positive infinity, f of x also approaches positive infinity. So only the first 4 problems are dealing with end behavior. I'll make another video about finding zeros. Let's take a look at this. So we have this kind of factored polynomial. Don't square this. Don't write this out 4 times. We don't need to spend forever distributing. What you kind of want to get in the habit of thinking about is what is our biggest x, or what is our leading term, really, but what is the biggest x? The coefficient only matters if is it positive or negative. We don't care about the numeric coefficient. Alex will show you how to do the numeric coefficient, and that's fine, I guess. But we can think about it that way. If we distributed this -6, then we would get a -6x. That would be the highest degree x term for this first polynomial. I would get a -6x. I don't care that I would get a -24. That's not going to help us determine end behavior. What would I get over here? 3x minus 1 squared. If I FOIL this out, 3x minus 1 times 3x minus 1, I would get a 9x squared. Again, we're looking for the highest x value. I would also get, -6x, but we're looking for our biggest x term. We don't need to know what the entire polynomial is. So we did this polynomial, x plus 5 raised to the power of 4. If I wrote this out 4 times and distributed and did all that foiling, we would get an x to the 4th power as our highest x. And that's how this is going to work. Here we had like basically an exponent of 1. So x to the first power. Here we would get an x squared. Here we would get an x to the fourth. We would also have, other terms in the polynomial. But we only care about the leading term. It's the leading term that determines in behavior. So negative 6 times 9, that's negative 54, but we don't care about the 54. We care about the negative, and then we have x times x squared times x to the fourth. Add those exponents to get x to the 7th. So you just need to find what your biggest x value would be. And here we are negative and odd. Negative and odd. Like y equals negative x. A linear equation going down from left to right. And so that is your in behavior. Sometimes you'll see it like this. It'll just have like the left arrow, the left in behavior, and the right in behavior. It might ask it in this kind of notation. Or in class, you might see it as left hand rises, right hand falls. Finally, we'll do number 4 as well. Something like this. It's a negative 2x squared times 2 minus x times 4x minus 5 cubed. So we would have a negative. We can pull in the coefficient if it helps us think about it. A negative 2x squared times a negative x. Bring in this sign. It's a minus sign in front of the x. And then we would get 4 cubed, which is 64, and then x cubed. Again, we're just looking for the biggest x term that we would get out of 4x minus 5 cubed. I don't care about the numbers of the coefficient. I care that a negative times a negative is positive, and I would get x to the power of 2 plus 1 plus 3 is x to the 6th. And if we want to raise to any power, we use this little arrow button, x to the 6th. We got this U shape going up from left to right. Because here we are positive and even on the exponent, which is just like x squared, which makes a U shape. So left hand up, right hand up. So that helps. And next time we will look at finding zeros.